for our customers instead. Now let's put the chicken noodle soup back in place and declare a new variable named customer is banned, which will hold Boolean data. We'll add an if statement that checks if customer is banned is true. If it is, we'll reply, no soup for you. We can add a new variable, leave our variable, but if true, code our programmer. If statements are a great look at the basic syntax of an if statement. I'd add it onto our statement. Soup for now. The condition of our if statement is the value of soup. We are saying if soup has a value, set the reply variable equal to our string value. Let's use a template literal so we can include the value of soup in the string. And we'll finish by logging the reply value to the console. If the value of soup is false, which can also mean undefined, null, or equal to 0, our code will skip right over the if statement. However, that's kind of rude if someone asks for soup and we don't reply. Let's add an else clause to apologize for not having any soup to fulfill their request. Let's use a template literal string again so we can include the value of soup. We also need to delete the value of soup while leaving the variable undefined in order to see our else clause in action. Upon saving our changes, you can see our else clause says, sorry, we're out of undefined in the console. That's not a great message to deliver, but it proves undefined data is considered false. Let's change the reply to a message for our customers instead. Now let's put the chicken noodle soup back in place and declare a new variable named customer is banned, which will hold Boolean data. We'll add an if statement that checks if customer is banned is true. If it is, we'll reply, no soup for you. We can make this part of our previous if statement by using an else if before we check the value of soup. It is important to think about the logical order of an if statement. Why would we check for soup if the customer is banned? They can't have soup even if we have it ready to go. Therefore, we should check if the customer is banned before checking our soup status. Let's add one more variable named crackers. Crackers will also hold Boolean data. Now let's copy our else if clause that checks soup and paste it back into our if statement. Now we will modify the condition. Instead of just checking for soup, we are checking for soup and crackers. This condition once again needs to come before our condition for just soup. If the condition for soup was above our condition for soup and crackers, all orders for soup and crackers would just stop when the condition for only soup was true. No one would get their crackers. If we don't get the logical order correct, we could have angry soup customers. All right, let's move on to a new example that most of us should be able to relate to, test scores. We'll define a test score variable with a value of 89, and also a grade variable that we'll leave undefined. Instead of just checking if the test score value exists, we will add the greater than or equal to 90 stipulation. If our test score meets this requirement, our grade is an A. We don't have an A, so our code will just skip over the rest of the statement. If we log the value of the grade variable to the console, we get undefined. The logical order of an if statement is like a waterfall. As we add the if-else clause to our statement for a B grade, we can simply say if the test score is greater than or equal to 80. This is because any score 90 and over will not make it to this part of the statement. It is the same as saying any score from 80 to 89 because of where the clause is positioned in our statement. Let's go ahead and complete the rest of the grading scale. As we get to the end of the grading scale, we can just use an else clause because we already know that any test score that makes it to this part of our if statement is going to be less than 60. Let's do something different inside the else clause. We'll start with a new college student variable with a true Boolean value. Inside the else clause, we will nest another if statement. That's right, we can nest if statements inside of if statements. In this case, if college student is true, the failing grade is U for unsatisfactory. Otherwise, the failing grade is F. Let's try it out by changing the test score to a 59. Okay, one more example that will really highlight decision tree thinking. My goal is not to execute this code, but rather give you an outline of a simple rock, paper, scissors game. After the tutorial, take the next step and complete the code on your own. The first condition we will look for is a tie game. If we do this later, we will have to keep repeating the code in each clause. It is logical to look for a tie game first. In the first else if clause, we'll check to see if player 1 has a rock. If so, a nested if statement will check if the computer wins or player 1 wins. We don't have to worry about a tie game because of our logical thinking to start off the if statement. We can repeat this pattern for paper. And as you might have guessed, we just need an else clause for scissors because it is the only option left for player 1. Now you have a full outline for a rock, paper, scissors decision tree. That wraps it up. I hope you've gained insight into if statements and their logical patterns. Switch statements are another tool for making decisions with JavaScript. Let's take a look at the switch statement syntax. A switch statement checks an expression or value and then takes a waterfall shape to check any number of possible cases. The logical order of the cases is important. If case 1 is a match, the switch statement should be stopped with a break command and never make it to the evaluation stage of case 2. After any number of possible cases, switch statements are completed with a default option that is chosen if none of the above cases are a match. Now let's look at an example. We'll start by evaluating a string with a value of 2 in our switch statement. We'll set up case values for numeric data of 1, 2, and 3. If there's a match, we'll log an appropriate value. If there's no match, we'll log a string saying no match. What do you think will happen? If you said no match, you're right. The numeric cases will not match the string value of 2. The data types do not match. Switch statements need strict matches. If we change the evaluated data to numeric type, we'll start to see some matches. You can also ask switch statements to evaluate an expression. Let's put the random number expression that we previously learned into our switch statement. We'll have it generate a random number from 1 to 3. I'll save the file a few times to generate a few new numbers. This expression will never trigger our default result at the bottom of the statement. Let's change the expression to generate a number from 1 to 5 and see if we can get the default option after a save or two. Let's apply a switch statement to the decision tree for rock, paper, scissors. We'll start with two variables, player 1 and computer, both set to rock. We'll pass the value of player 1 to our switch statement. The first case will evaluate player 1 to see if it is identical to the computer value. If this case matches, we'll log tie game. We'll then create cases for each value of rock, paper, and scissors. However, scissors will just be the default option since it will be the only possible outcome at that point of the statement. I'll quickly finish typing the code and we'll check the results of the statement. Let's change the computer variable value to paper and see what result we get. Now let's change the value of player 1 to scissors and look at the outcome. And finally, let's change the value of computer back to rock and check the result. And there you have it. Switch statements are another tool in your JavaScript decision-making arsenal. Developers often try to avoid using switch statements for a variety of reasons, but sometimes they are necessary. Switch statements are an important fundamental to know. The ternary operator is a three-part tool for making decisions with JavaScript. Let's take a look at the ternary operator statement syntax. You can think of a ternary operator statement as being shorthand for an if-else statement. Like an if statement, we start with a condition. After the condition, we put a question mark. If the condition is true, the result of the ternary operation is found here. This is followed by a colon. The colon is like the else in an if-else statement. If the condition of the ternary operator is false, the result of the ternary operation is here. Let's look at an example. Let's start by defining a variable named soup and assign it a value of chicken noodle soup. Now let's define another variable named response. We'll assign the result of a ternary operator statement to this variable. We are saying if the variable soup holds a value, our response will be, yes, we have soup. Otherwise, we will reply, sorry, no soup today. We can see the value of our response variable when we log it to the console. If we remove the value of our soup variable, it will be undefined, which is considered false. Now our response will change because soup will be evaluated as false with the ternary operator. Now let's delete that ternary operator statement and add another variable named isCustomerBand with a true value. We'll set a variable named soupAccess equal to the result of a ternary operator statement. If isCustomerBand is true, soupAccess will be equal to sorry, no soup for you. However, if isCustomerBand is false, a second ternary operator statement will be activated. That's right, you can chain ternary operator statements together. This second statement is much like our first example. I am putting each part of the ternary operator on a new line. The Visual Studio Code extension Prettier will format it nicely when I save the file. We can see our console output for soupAccess is sorry, no soup for you. If we change the value of the isCustomerBand variable to false, the second ternary operator takes action and evaluates the variable soup as true. Again, if we remove the value of soup and leave the variable undefined, the second ternary operator will evaluate soup as false and provide a different value for our soupAccess variable. Now let's look at a grading scale example. We'll start by defining a variable named testScore and giving it a numeric value. Next, we'll define a variable named myGrade and assign it the result of a ternary operator statement. We will have the ternary operator evaluate the test-score number and return a letter grade as the value. Just like if-else statements, chaining ternary operators results in a waterfall-like behavior. Therefore, when we get to the second ternary operator, we already know the number is less than or equal to 89, so we only have to check if the number is greater than 79. This chaining pattern continues until the result is a failing grade when none of the ternary operator statements are true. Let's use a template literal string to print the value of myGrade to the console. Now let's change the test score value a few times to check the results. Now let's apply ternary operator statements to rock, paper, scissors logic. As with the tutorials on if-else statements and switch statements, we want to check for a tie game first. From there, we can chain ternary operators together. Each ternary needs to evaluate both the value of player 1 and the value of the computer variables. When we reach the end of possible winning outcomes for the computer and none of those are true, player 1 wins by default. Let's change the variable values a few times to check the resulting outcomes. There you have it. Ternary operators are next-level if-else statements. Once you understand how to read them, ternary operators usually save you lines of code compared to the bulkier if-else syntax and switch statement syntax. Most simple ternary operators only require one line of code. As we get started today, you'll see I have Visual Studio Code on the left side of the screen, and on the right side, I have Chrome open to DevTools. You're not seeing much of the actual web page preview that I have in mobile mode at this point, so I'll just drag that back over because we don't really need it. What we want is the console, and we're going to look at some pop-up boxes we're going to interact with the user of the web page with. And the very first one that we'll come back to is kind of a refresher because we had it in the very first tutorial in this series, and that is the alert pop-up. And it just shows the user some information and asks them to click OK. You don't really get any other data back from that. So we just put in hello world, as we did in the first tutorial for our hello world. When I save this, you can see on the screen we get the pop-up box. It gives the name of the website, and in this case, it's just my local IP address, 127.0.0.1, and then 5500 is the port number. And that's because I'm using the live server extension in Visual Studio Code, as I do in most of these tutorials. And it says hello world. And all the user can do is click OK. There's no real data coming back. We just wait for the user to respond to the prompt, click OK, and we're finished with that. However, the others we'll discuss do return data. So let's look at what we can do there. Instead of just an alert, we can put in a confirm. And I'll put exactly what happens or what it returns in the text we display. So OK equals true. Then I'm going to put in a line break. That is a backslash and an N. That equals a line break. And then I'm going to put cancel equals false. And that is what a confirm returns. So let's go ahead and save that. You'll see the box pop up. Once again, you get the website name, and then it says OK equals true, cancel equals false on 2 lines, and that's what we entered into our confirm. And if we click OK, the confirm returns a true value. And if we click cancel, it returns a false value. But we didn't put anything there to receive that data. So let's go ahead and define a variable called myBoolean. And now let's log myBoolean to the console, just so we can confirm we are receiving that data back as expected. Save that, and I click OK, and you see true in the console. Save it once again to relaunch it, and I click cancel, and we get false in the console just as expected. So that's great. Now let's look at the third type of pop-up we can use, and we'll put a variable named name, and it's equal to a prompt. That is the third type, and we'll put in here please. Please enter your name. We're actually asking for direct input from the user, where the user gets to type into an input box, and we will get the value back in return. So let's log that value so we can see what happens. And here's the input box as it pops up and it says, please enter your name. I'm back in the code here. I need to type in the box. Enter my name, and that's what we see in the console. But you notice there was also a cancel button. What happens if we click cancel? Let's see what we get. We get a null value. So we have to plan for that because we can't do the same things with a null value that we can with string data, which is what we got back when I entered in my name. So we have to check for that. And null could also translate as false, just like undefined data can, just like the value of 0 can, and of course the Boolean value of false. So we can check for that in a couple of ways. One newer way to check for that in JavaScript is with the nullish Coalescing operator, and that is 2 question marks. And this will say if name has a value, log name to the console. And then if it does not, if it's null or undefined, go ahead and send this to the console. And we'll put you didn't enter your name. So now if I click cancel, the console says you didn't enter your name. But if I go ahead and enter my name, click OK, we get Dave. So that is how the nullish-Koleskin operator works. However, there's an issue here as well, and let me show you what could happen. I won't enter anything, and I'll click OK. And now we just got a blank line. That's not so great either. Let's check just to make sure what type of data we get when we just click OK. It's still string data. It's just not really anything. And so we would want to check for that possibly by checking the length property with an if statement, something along those lines. So what we could do is put if, and then just check the length property, because if there is no length, it will be 0. And so that would make it false as far as this evaluation or this if statement evaluation goes. Save that. We won't enter anything and click OK. And nothing happens because it doesn't pass the evaluation of this if statement. So then we could put else, and essentially we'll have the same response of you didn't enter your name. So now we've got you didn't enter your name from line 6, as you see here. And if we click cancel, now we're checking the length property and it's null. That won't work for us. So what we better do is check to see if name exists at all. And that might be a better solution. If we just check the length property, we can't do that with null. Likewise, we can't check methods with null. We can with a string though. So checking properties and methods before checking for null with the nullish-Koleskin operator, or as we're going to now with just if name has a value. And if it doesn't, null won't pass this test. And so that might be a better way to do this whole thing, really. And we could still have you didn't enter your name. And then here, all we really need is to log name. That's a little more concise too. So let's check that out now. If I click OK, we get you didn't enter your name. And now I'll just make a change and save it again. If I click cancel, you didn't enter your name. And if I enter my name, it's OK. And so this works a little better for us. So we really have to be prepared to check that user data that is entered. Now, there could be something else that comes up. Maybe there's a lot of extra white space, something like that. And of course, we could also check equality for specific values if we're looking for specific values. But white space is something that comes up fairly often. So let's do this just so you can see the issue. After we know name exists, we can check the length. And then let's check the length again after we trim the white space with the trim method, and then I'll chain the length property onto that. And then when we log to the console, the actual name, we'll trim that as well. So now I'll type my name, leave a lot of spaces afterwards, spaces that we wouldn't want in a database. We wouldn't want taking up space when we repeat the data back to the user or on a web page. Click OK. Look, it was 65 characters long before we trimmed it down to the actual 4 characters without the white space that could be at the beginning or the end of the string. It will trim both. And then we logged the name to the console. Today we combine all of the knowledge you've previously learned from the tutorials, data types, conditionals, numbers, how to generate random numbers, how to get user input and use it and handle it. All of those things will come together today as we build your first interactive game. And so we will start out by defining a variable called playGame, because we need to ask the user if they want to play a game to begin with. And we'll do that with a confirm box that should pop up, and we'll say, shall we play rock, paper, or scissors? And I'm going to get our code to wrap. And there it already asked if we shall play rock, paper, or scissors, but we're not ready to yet. But I did save the code, and so it launched the code right away. And what we need to do from there is check the value of the playGame variable. So if playGame actually holds a value, in other words, if it is true and has some type of value, it is not undefined, it is not null, then we're going to play the game as the user wants to. But we might as well put a message in an else clause just in case the user has clicked cancel in the confirm, and then we could just say something with an alert for the user and say, okay, maybe next time. Now we're ready to play. And since we're ready to play, we need to let the player make a choice. And being courteous, we'll always let the user go first instead of the computer. So we'll say let player choice. And now we will issue a prompt to the user asking them to make a choice. Please enter rock, paper, or scissors. And there our code wrapped. to the next line, and you can see on line 5, it's just a little bit taller because it's taking up a second line. Even though it's just one line of code, Visual Studio Code is wrapping it for us so it doesn't extend further to the right. And now that we've asked for that prompt, we need to handle the data that we get in return. And the very first thing we need to do is check if we received data in return. If the user clicked cancel, we would get null, and we don't want that. So we have to check to find out. And if that player choice variable actually holds a value, which is what we're saying here, then we can continue to play. But if not, we'll assume the user changed their mind. So we'll say, alert, I guess you changed your mind. Maybe next time. But we'll only make it here if player choice has a value. Now we need to assign that value. We need to handle the user input actually and assign that user input after it's handled to our player1 variable. And so we will go player choice, and we'll trim any white space, and we'll set it to lowercase because we don't want to check every possible value for the word rock with the different capitalized letters and lowercase letters. So we set it all to lowercase so we can just check for one specific lowercase value of rock, one specific lowercase value of paper, and one of scissors as well. So we have our player1 variable now ready to go, and now we need to find out, is it rock, paper, or scissors? We'll use an if statement. We'll say if player1 equals rock, and we only need to check for the lowercase word rock because, as we said before, we set it to lowercase, we trim the white space, so we'll just check for that. Now double pipes, and that means or. So now we can say or player1 equals paper, or player1 equals scissors. And now we can do something if those are true. But this is our third if statement, and it's nested inside of our second one. If none of those are true, let's say I just entered my name, we need to return something else. And so at this point, we can just say, alert, you didn't enter rock, paper, or scissors. But now that we know at this point, player1 has actually entered rock, paper, or scissors, we're ready to move forward. And now it's time for the computer to make its choice. We will do that by defining a variable called computer choice. And we're going to set that equal to a random number. If you remember how we define or pick a random number, we'll use the math floor method, and then we'll use the math random method, and we'll put 3 in there. We have to add 1, or remember it would be from 0 to 2, but we need this to be from 1 to 3. So we have our computer choice, and it's going to generate a random number from 1 to 3, and now we can use a ternary statement to assign the computer value of rock, paper, or scissors. And so we'll say let computer, and now we'll start our ternary statement by saying computer choice, and if that equals 1, the computer will choose rock. And then this is our else, and our else will just check the next value. So we'll say let. So we have our computer choice, and it's going to generate a random number from 1 to 3, and now we can use a ternary statement to assign the computer value of rock, paper, or scissors. And so we'll say let computer, and now we'll start our ternary statement by saying computer choice, and if that equals 1, the computer will choose rock. And then this is our else, and our else will just check the next value. So if the computer choice equals 2, computer will choose paper. And now we don't even need to check the computer choice because this is the third and final possibility. So we'll just say scissors. And now the computer has made its choice. And at this point, we are ready to just pull in the logic for rock, paper, scissors. And in the previous conditional tutorials, we did that logic already with an if, then, else statements. We did switch statements, and we did the logic with ternary operator statements. And that's what I'm going to pull in here. And I'm just going to copy and paste because it would take me a little bit to type it. But let's look. In just a second, we'll analyze what I paste in. And I want to move this back out just a little bit. There we go. We'll put a line here. So we're assigning the outcome to the variable result. And at first we check to see if player1 has tied with the computer. And if so, result equals tie game. And then the else of the ternary operator checks another condition. So we're chaining ternary operators, just like we did with computer choice. And here, we're checking to see if player1 equals rock and computer equals paper. And if so, we're going to return a template literal string. And that is, we use the backticks to start those. That is because we want to include the value that player 1 chose, and we want to include the value that the computer chose and show that the computer wins, but it wouldn't do any good to just show the computer wins. The user would go, why does the computer win? I don't even know what the computer chose. And so that's why we use a template literal string to show what each player or person in the game and computer in the game chose, and then what the outcome is. And we follow that logic through for if the player 1 had paper and the computer had scissors, or if the player 1 had scissors and the computer had rock. All of these possibilities lead to the computer winning. So when we get to the final one, the only possibility left is player 1 winning, and we issue that value here. And it comes back into the result variable, and then we just use an alert to let the user know who won the game and what values were chosen. But after that, we can go ahead and ask the user if they want to play again. So let's define one more variable, let play again equal, and let's use a confirm, and we'll just ask play again with a question mark. And now we can use a simple one-line ternary statement to handle this action. So we'll just evaluate play again, and if true, which confirm returns a true or false, if true, we're going to use something you haven't seen yet, and that is location with the reload method, and this will reload the web page, which will start the game over. And if false, we'll use an alert and just say, okay, thanks for playing. And let's save all of that. Prettier reformatted the code just a little bit for me. That's the prettier extension in Visual Studio Code. So let's look at this top to bottom before we start. We're going to ask if we want to play a game. If we want to play a game, we start to play. But if not, way down here at the bottom, we'll say else, okay, maybe next time. The next step is if, yes, we've decided to play our game, we ask the player to enter rock, paper, or scissors. If they enter a value, we're going to play our game. But if they don't, they've clicked cancel, and that means we get the alert, I guess you changed your mind, maybe next time. Up here, we'll assume they went ahead and entered a value, and now we need to check if they actually entered rock, paper, or scissors. If they did, the game proceeds. But if they didn't, for some reason, our else here catches that, and it just says you didn't enter rock, paper, or scissors. However, if they did enter one of those values that we can work with, then we let the computer generate a random number, and with that random number, we make a choice of rock, paper, or scissors for the computer, and then we evaluate the game now that player 1 and computer both have their rock, paper, or scissors, and we use this ternary statement to go through the game logic, and we get to the bottom of the logic, and we alert the player to who won the game and what each player chose, and then we ask the player if they want to play again, and if they don't, they get okay, thanks for playing, and if they do, the game reloads and starts over. So make sure this is saved, click cancel here, reload, and we're ready to play. And you can see at the top of this confirm, it has the website address, which is my local IP number, and then a port number of 5500, and that is with the live server extension in Visual Studio Code. And it says, shall we play rock, paper, or scissors? Well, this first time, let's just cancel and make sure we got that logic right. It says, okay, maybe next time, and it's done. So let's reload. Shall we play? We'll say, okay, let's play. So enter rock, paper, or scissors. Well, maybe we'll just cancel. I guess you changed your mind, maybe next time. Let's reload again. Shall we play rock, paper, or scissors? Okay, enter rock, paper, or scissors. I'm going to enter Dave because I'm just not thinking about the game. And it says you didn't enter rock, paper, or scissors. So far, all of our logical if-then statements are working correctly. We'll reload. This time, we'll go ahead and play. And we'll enter RO in caps and then CK in lowercase for rock. And as you can see, our code works, and player 1 chose rock in all lowercase. Computer chose paper. The computer wins. We'll say okay. And ask if we want to play again. Well, let's check our cancel first. It says, okay, thanks for playing. That also worked correctly. Let's reload again. Yes, we'll play again. This time we'll choose paper. And computer chose rock, so player 1 wins. Seems to be working correctly. Play again. This time we'll say yes. And yes, it reloaded the page, and it says, shall we play rock, paper, scissors? Now this is one area our program might be able to improve upon because it's asking if we want to play again, and then it's immediately following that by loading the game and asking if we want to play. But that's not a big deal right now, so we'll continue to play, and this time we'll choose scissors. And computer chose rock, and the computer wins. Well, that wraps it up. I'll scroll back through the code, and of course you can pause the screen and look at any part you want to. Move it down just a little bit. And scroll on down to the bottom. But now you can see how the logic works and how we've actually made this an interactive game. Congratulations on completing your first game, and I bet you already have ideas for games you would like to make that follow a similar format to this one. The best thing you can do is practice and make something of your own at this point. We'll start today by looking at while loops. We'll start with a variable called myNumber, and we'll set it equal to 0, and then we'll compose our loop. It starts with the word while, and then we put a condition in parentheses, and I'll say my number is less than 50. So while my number is less than 50, we will do what's inside our squigglies. And at that point, we'll say console.log my number. So we will print the number to the log with the console log function, and then we will increase my number by 1. And there are a couple of ways to do that. So first I'll spell it out. My number equals my number plus 1. So we are reassigning a new value to the my number variable. And this way, each time the loop executes, we will increase the number by 1. So the next time my number is logged to the console, it will be incremented by 1. However, I don't usually do it this way. There is a little bit of a shorthand for increasing or incrementing a number by 1. This is called the post increment. And so right after the variable, we put 2 pluses, and it will do the same thing. It will add 1 to the variable my number, reassign the value. So if it's 0, the next time it's 1, the next time it's 2. You get the idea. I will save the file, and this should execute. And there you can see, it starts at 0, and it goes while it is less than 50. So it ends at 49 here in our console. If we wanted to go from the number 1 to the number 50, we could do that a few different ways. We could start with the number 1, and we could say, while my number is less than or equal to 50, you can see we get 50 over here. We could also go back to 0 and go back to less than 50, and we could increment our number by 1 each time before we log it to the console. And that way it's going to satisfy the requirement that it's less than 50 when it's 49, and then we'll increment the number to 50 before we log it to the console. And you can see we have 50, and we start with the number 1. So there are several ways to think through what you're trying to achieve with a loop like that and incrementing numbers. We could also increment by 2 or something else, and you can really increment by any value you want. There's shorthand for that as well. Instead of saying my number equals my number plus 2, we can say plus equals 2. So every time the loop executes, it will increment by 2. And here you can see it goes 46, 48, 50, and we get the result we expected. One thing to remember with loops, do not create an endless loop. And I'll put that here in a comment. Don't create an endless loop. And that is because it will just kind of go on forever until you run out of memory. You're going to end up probably trying to close out of your browser or closing out of the tab. There are other ways to stop a loop. If you have more than one tab open, the first thing you should probably do is try to close the tab. There is a documented way to do it in Chrome DevTools, but it's not as easy to do as you may think. You kind of have to catch the code between those little tiny milliseconds of executing to hit it just right to get it to work the way it's supposed to. The easiest way I've found is to close the tab or close the browser. At some point, working with loops and learning, you're going to forget, essentially, to increment the number or whatever meets the requirement to stop the loop, and you'll create an endless loop, and you'll find out what I mean. So don't feel bad if you do it. Okay, the next loop we want to move on to is a do-while loop. It is very, very similar to a while loop, but the main difference, let me just come back up here and do this right here. We'll say do, and then we'll get rid of the requirement here altogether. Do, and then we'll put the while afterwards, and we'll put my number is less than 50. Let main thing to remember with a do while loop, really the only difference, is it's going to do this at least one time. So if I come back, let me just reverse that by an undo. There we go, we've got our loop back the way we had it. This, if we set the number to 50, this won't do anything. We got nothing in the console. However, if we create a do while loop, it will do this, and we'll say console log my number, and then we'll put the while afterwards, while my number is less than 50. Now let's see what happens. We got 50 in the console one time, and that is because with a do while loop, you're going to execute this code block at least once, even if this requirement is not met. What happens in the do block will happen at least once, and that is a huge difference between just the while loop and the do while loop. Now let's delete most of this. We'll keep our my number variable. We'll set it back. Well, we don't even need that right now. Let's get rid of that too. And we're going to look at a for loop. A for loop is very common in JavaScript and in some other languages as well. And it starts with the word for, as you might expect. And then it's got 3 components inside its parentheses. And the first is the variable. Many times you'll see a variable with just a letter like I for integer or x or something like that. You could use any variable name you want, but many times you'll see something just like this with let I equal 0. And then maybe while I is less than or equal to 10, the loop will execute, and then we'll increment I by 1 each time the loop increments. And then we'll log to the console the value of I. So let's check this out. Yes, we've got 0 through 10 because I said less than or equal to 10. If I had said less than 10, it would stop at 9. Or we can start the value of I at 1, and then we could say less than or equal to 10, and we would simply get 1 through 10 instead of 0 through 10. Different ways to construct the loop. Also, you can break these things out of the 4 parentheses. This would not have to be here. You could leave that empty. You would still need the semicolon after the condition, and you could increment I at the bottom of the code block of the for loop. Just like this, the same thing exactly happens. You could even define I before the loop, and the same thing would happen. But it still has those 3 spaces that you have to allow for the for loop. So most of the time when you see a for loop constructed, you will see all 3 inside the parentheses. So you define the counter variable, and sometimes you'll see it named counter, and then you put the condition, and then you increment. Well, you don't have a semicolon there though, because that's the end of that. And that's pretty much it. Let's run it one more time to make sure we don't have a typo. Yep, we're good. And that is a for loop. However, for loops are much handier than just counting to 10. You can loop through many things in JavaScript. So let's do something else with the for loop. Let's define a name. We've done this before. Name. I'll use my name, Dave. And now in the for loop, instead of saying while I is less than or equal to 10, let's say while I is less than or equal to name.length, the length property. And now, when we log to the console, instead of just logging the value of I, let's go ahead and log name with the character at method and put I in there. Oh, 1 extra parentheses there, we're good. And we want to start I at 0 because the first letter, the capital D in my name, would be at position 0. Now, when we do that, we get each letter of my name on a new line in the console. So you can see we can break up things and execute different values. In the future, we'll learn about data objects and arrays that we can go through and handle each item in the array or each item in the object with this similar type of method in constructing loops. So that comes in very handy. Or each item in the future, we'll learn about data objects and arrays that we can go through and handle each item in the array or each item in the object with this similar type of method in constructing loops. So that comes in very handy. Now let's also go back and look at a while loop and just think about what else we could do with it, or maybe something similar to what we just did. I'll go ahead and start here, and we'll define something called counter, just to have something different. This will be our counter just like I was. And now with the while, one thing I didn't show earlier is we can just say while true. Now this will execute forever unless we use the keyword that I'm about to show you. We'll go ahead and define another variable named myLetter. And let's have myLetter just be undefined for now. But then once we get into the loop, oh, we need my name as well. So let name, we'll bring that back. Once we get into the loop, we're going to define myLetter because myLetter is going to be equal to name and counter, which is our counter variable. And as you might guess, we're going to need to increment counter as we go through the loop. But this would keep happening forever, and eventually, of course, we'd have an error because once we got past the number 3 for counter, we'd run out of letters in my name, 0 through 3 for the position letters. So what we want to do is go ahead and log my letter while we have a letter. And then let's say if my letter equals, let's not wait for the E, let's go to the V. If my letter equals V, break. We're going to use the break keyword and we'll break out of this loop. Now save that, and you can see we get DAV. So you can create a loop that just continually executes until you get the value you want, and you can specify that condition within the code block using the keyword break to stop the loop, rather than putting the condition in the parentheses of the while. And as you might guess, you can also do that with a do while as well. You could even create a for loop that goes on longer than you need it to, and then use the break keyword to get out of the loop. Now that we've talked about the break statement, sometimes I say keyword, statement, keyword, we need to add the continue statement into the discussion as well. And so let's modify this loop just a little bit. We'll once again say why counter is less than or equal to 3, because we don't want to go on forever with the changes we're going to make. And then we'll leave this line the way it is. And notice I am, of course, pulling the letter out of the name with brackets instead of using the character at method, but this works in the same way. And then we have console log my letter, and we'll continue to log the letter. But after that, let's add another if statement, and we'll say if counter equals 1, we're going to activate some code within this block, and we'll say counter plus equals 2. We're going to add 2 to counter if it equals 1, which will immediately make it equal to 3 instead of 2, which is what we would normally do with the increment down here at the bottom of our loop. And after that, we're going to use the continue statement. And the continue statement says, all right, continue the loop back at the top. Skip the rest of the loop. And so we're going to skip this increment. We're going to skip this if statement where it checks to see if the letter is V or not. And so if we think about this, we're going to come in through the loop and it'll be 0 and it'll execute the way we expect it to. It will be 1, and when it gets to the counter, gets to 1, it will stop here. It will increment by 2 and then start again. And at this point, it will be equal to 3. And so when the loop is equal to 3, it will execute one more time. It will come in, it will print the last letter of my name, which should be E, and it'll send that to the log. And from there, it'll come down here and it won't be equal to V, so it'll skip that. It will increment counter one more time, but we won't use it after that. So in the end, counter will actually be equal to 4, and we'll be able to see that once we break out of the loop. So I'll go ahead and log counter as well. just so you can see that value. And let's go ahead and execute this by saving the file. And as expected, we got DA, and at this point, this was position 0, position 1, and then we added 2, skipped the rest of the loop with a continue statement, and executed the loop one more time, and grabbed the letter in the 3rd position and sent it to the console, and then we were finished with the loop. And then when we logged the value of counter, it was actually equal to 4 when we finished our loop, because this applied one last time at the end. And that is the continue keyword. You've already used some functions and may not have been aware of that. So let's discuss that for just a moment. Methods really are built-in functions. And so if we have a string like my name, and then we call a method like, oh, let's say to lowercase, we're calling a function, but it's called a method because it's already built in to JavaScript. Another example, oh, it wouldn't even need to do that. We'll just say math random. That is a built-in function as well. But when we define functions, actually when we declare functions, we are making our own code blocks, our own reusable code blocks. And that is what is so important about functions. Our code becomes more efficient. We can call that block of code as a function again and again and again. So let's define some of our own functions, and we'll start with the function declaration syntax. So you can learn each part how to make a function. We'll start with the word function, and then we need to name our function. And let's start with a basic one and call it sum. After that are the parentheses, which are the operators. And we will put parameters in there, but not right now. And after that comes the curly braces. And inside this code block that is held with the curly braces, we put our code that we want to execute. And here we'll put a return statement, and this is the value that the function will return. And we'll just start with 2 + 2. And right now we have declared our function. I'll save the code, and we won't see anything in the console because we haven't sent anything to the console. We haven't even called the function yet. A function needs to be called into action. And just to see the result of the function, I'll create a console log, which is actually its own function or method that was predefined. Now we can call our function. Notice that I have to put the operators afterwards to call it into action, the parentheses after the word sum. And now when I save the file, we get the result of 4 in the console. And that's because we're returning the sum of 2 + 2. Now, if we want to always get 4 back when we call our function, I guess this would be reusable, but it's really not that functional. So let's go ahead and add some parameters in our function. We'll say num1 and num2. And now when we call the function, we need to provide those parameters. So let's say 2 and 6. So we are providing 2 parameters when we call the function. And in our declaration, we're prepared to receive 2 parameters. I'll save the file. Oh, I didn't change in the body. Also need to change that. So I referenced the parameters and not the absolute values I had in there previously. And now we get 8 in the console as expected. So this makes this a much more reusable function. We can accept any 2 numbers, and then we'll return the sum of those numbers. Let's see what the result is inside the function when we log those, and maybe we will forget to provide one of those. So we have our definition here, our declaration of the function. I'm only going to provide one number, one parameter when we call this function. I'll save this. Notice in the console now, we get 2, which is num1, our first parameter. The second parameter is undefined. And so when the function attempts to add those 2 parameters together, it gets not a number in return because it cannot handle the undefined number. So maybe we could prepare for that. We could add some extra code in our function and say if num2 equals undefined, then we should just return num1 plus num1. Save that. And now you can see in the console, once again, we get 4 because we're getting the sum of 2 + 2. If we call the function with 5, we get 10 because we're getting the sum of 5 + 5. However, we can go ahead and call it with 2 parameters as well, and the function returns the sum of num1 and num2 because num2 has been provided. Let's look at another example. We'll delete our first example function, and we'll create a function called getUsername from email. And this function will accept an email address. And now we want to return the first part of the email address before the @ symbol. So we want to eliminate the @ symbol, and we want to eliminate the domain from the returned value. So we will go email.slice. So we're calling a method inside of our function. We want to slice at the very beginning. We want to keep that first part of the email. And now we'll tell the slice method with its second parameter where we want to stop. And we'll use index of, and we'll look for that @ symbol. So we know to stop there, and it will not include the @ symbol. So this function accepts an email, and then it returns the first part of the email. Once again, we've just defined it. So when I save the file, we don't get anything in the console. Now I'll make a console log statement, and inside the console log statement, we'll see that Visual Studio Code recognizes the name of our newly created function, wants to help us out right away. So I will put player1@somerandomemail.com. Apologies if that is truly an email. And now save the file, and you can see in the console we just get player 1 because our function eliminates the last half of the email. It eliminates the domain and the @ symbol. And we can reuse this. So we could use this with, let's just say user@github.com. Once again, apologies if that is really somebody's email. And now we just get user in the console. So our function is very much reusable and should work for any email address. Let's look at another way you might see functions declared, and that could be as anonymous functions. If you don't provide a name, it is an anonymous function. And then you might hold the result of that function, and I guess the entire function, if you will, inside a name, variable name, for example, that you would define. So this actually has the same result of what we had before. And you can see that by, I'll just put dave@davesdomain.com, save that, and we just get Dave in the console. The function still works as expected, but it is defined slightly differently. And now that we've looked at it this way, and you will see anonymous functions from time to time, and you'll definitely see them as you learn more about calling functions based on events on a web page. But let's also look at a newer way that functions are now defined, and these are called arrow functions. So let's eliminate the word function, and then after our parentheses that contains our parameter, you see an arrow, and that points at this code block, curly braces of the function. And this will also work in the same way. So I'll just change the front name here in the email, and this will be John at Dave's Domain. And now we get John. And so this is what you call an arrow function. Before we finish our first look at functions, let's create one more. So let's eliminate what we've got here. And we'll still start with the const instead of let is what I prefer to use for functions. And we'll use the name toProperCase, and we'll make an arrow function. We'll take a name, provide our arrow and our code block. Now we know there are the 2 lowercase and 2 uppercase methods, but JavaScript does not have a toProperCase. So we'll make our own. And here we'll return, and then we'll use the name parameter that we're going to pass to the function, and we'll get the character at the 0 position, which will be the first letter of the name, and we'll set that to uppercase with the toUpperCase method. And then we'll use the addition operator, and again, when we're working with strings, that should just mash together the next part, actually concatenate, if you will, the next part of the name, and so we'll use name again, and now we'll slice, but we'll not start at the 0 position, we'll start at the 1 position, so this will be slicing off that first letter that we've already set to uppercase. And now we'll call to lowercase, and this will return both of those. Once again, this is just a declaration. We have not got anything to return yet into the console window. We haven't called the function. So let's once again use the console log function just so we can see the result of our function. And here we'll call toProperCase. Visual Studio Code helped me out there. And now we can put any name in here. And so let's go lowercase d, uppercase v, lowercase v. I believe I said v before. So lowercase d, uppercase a, lowercase v, uppercase e. When we call this function, we'll pass, whoop, got that in the wrong spot. We'll pass that string, and in the console, we get Dave in proper case. And once again, we could do this with anything. I guess it's September right now. Let's put in the month of September. Any string we pass to our function, it will set to proper case. So that is our introduction to functions. Functions provide reusable code. And that is the main thing to take away. We can define blocks of code and call them when we need them. Today we're discussing the keywords var, let, and const. All 3 are used to initialize variables in JavaScript, and all of this will lead to a discussion of scope. But let's start with the keyword var, and we'll declare a variable x, then set it equal to 1. This is what was done in JavaScript from the very beginning up until 2015 when we introduced the keywords let and const. Var responds a little differently, and it's not always as good. As a matter of fact, var is pretty much relegated to legacy code, which is old code at this point, in preference for let and const. And let's look at why. We can define a variable like x with the keyword var, and we can log that to the console and see the value just fine. We'll see the value over there of 1. However, var doesn't throw an error if we redeclare that same variable. And now that variable's 2. But imagine if you're working on a team or you've got different files of JavaScript that are all pulled into a project. This could get very confusing and there could be problems, especially when an error doesn't happen and you really need that error to realize that something has been defined with the same variable name. So when we use the keyword let and attempt to do this, we get an error, and that is actually desirable in this case. Now both var and let will allow reassignment. And so there is no error here because we didn't use the keyword let again. We just declared the variable once, but then we reassign the value, and that's okay. If we use the keyword const, this will throw an error. And this makes const the preference for most. You want to use const whenever you can, and then use let when you know you're going to need to reassign a value. But if you know you won't be reassigning a value, const is short for constant, a constant value, just use the keyword const. Otherwise use let and leave var for legacy code. But now we need to discuss scope and the differences, because var has a different scope, and really the way it responds to scopes is different than let and const. As we move our discussion towards scope, let's start with global scope. And with global scope, we define a variable, give it a value, and it is available everywhere. And it doesn't matter with global scope if we use var or let or even const. They're all global variables when we define them in the global scope. So all three of these variables are global variables at this point. We have not defined the opposite of a global scope, which is a local scope. Inside of a local scope, and there can be more than one type of local scope. As a matter of fact, there's two. There's block scope, and inside of these curly braces, we can once again define, even with let or const, we can define a variable again and not get an error, as we see no error in the console. The other type I mentioned as a local scope is a function. And so for local scope, we have block scope and function scope, and they are not exclusive. We can put a block inside of a function. We can put another function inside of a function. I'll create a function now, and this scope, and I'll use const here, is also a local scope. Now when we look at local scope versus global scope, the variable we define, y for example, is not available. This value pair here, y, the variable, equals 4, is not available in the global scope. So if I comment out the y in the global scope, and then we put a console log statement in the global scope once again, and we try to log y, we should get an error. And that's right, we got a reference error, y is not defined. It is not defined in the global scope right now. It is defined in a local scope. And if we try to do the same thing inside of our local scope, we get 4 to the console, no problem. We can see the same with z. If we comment that out in the global scope, as you might expect, we will get an error, reference error, it's not defined. But if we add it to our function, and then we need to call our function, we get 4 from our block scope, and we get 5 from our function sent to the console. And let's take our local scope, that's a block scope, let's put it inside of our function. And that works too. Now when we call our function, we log the value of z, and the value is inside the scope of the function, which is also called function scope. But this is a local scope, but this is inside the function, so it's also a function scope. And this local scope, we've created another kind of environment, if you will, for a block of code with the curly braces, and this is inside the function. So let's come back up here, and instead of logging the value of z to the console, let's log the value of y, and at the same time, we'll uncomment y in the global scope. Now let's see what happens. The value of y that gets logged to the console the first time is 2, and that's defined in the global scope, because the values from local scope cannot move upwards. They do not go to the parent. And this scope is nested inside of a function, so it will not move up into the function scope. It stays within its block. So the only way that the function gets a value for the variable y is to get it from the global scope that is available to all. So I think you can see a pattern here. The global scope is available to all. It can go in functions, and beyond that, it can go into other functions that are nested in a function. It can go into blocks of code that are in a function. Now, I've just got the 2 curly braces here to define a block of code, but you've seen blocks of code before, not just with curly braces like this, but you've seen it with if statements, and I'll just put if true, and that code should still execute. You have seen curly braces, which essentially create blocks of code with for loops. I won't put in the full body of the for loop there. You've seen curly braces with switch statements, and a variety of things. So what you're doing when you have that is creating a local scope that is a block of code. And if you use let or const inside a code block, it works perfectly fine, and it will not conflict with something that is in a parent or in the global scope. But these values, like the value of y here, as I declared with const, is not available to this function anywhere except in this block of code, in this code block with the curly braces. Likewise, it's not available in the global scope. So the code values, or the variable values, can be passed down, global into functions, functions into other functions, or blocks of code, but they cannot be passed up. Scope is a concept that is hard to take in and process at first, and so I'm going to delete what we have and we'll come back and do one more example as a walkthrough to help you process this information and hopefully explain it as clearly as possible. So we'll once again start out in the global scope with X, Y, and Z, and we'll put in some console log statements using template literals that make it just a little bit clearer. See, now we have global 1, 2, and 3. The next thing we'll do is create a function, just like we had before, function myfunc. And inside this function, we will once again log to the console the 3 values. Here I will put function. We haven't called the function yet. And then inside the function, we'll create a block. And inside this block, we'll once again log all 3 values. And we'll make sure it says block there. Now we aren't seeing those extras until we call the function. So at the very bottom, I'll need to call the function. And now we see global 1, 2, 3, function 1, 2, 3, block level 1, 2, 3. And they're all saying 1, 2, 3 because even though we go into the function, which has its own local scope, and even though we go into the block, which then has its own local scope, there are no extra declarations. So the block looks for those definitions and doesn't find them in the block, so it moves up to the parent and it doesn't find them in the function. Once again, it moves on up to the global scope and gets the 1, 2, 3. And function does the same when it comes up there. Actually, function would look up here first, pull in the values, and then the block would look up to the function and pull the values from the parent. So it's always pulling from the parent. Let's make a definition or two, or a declaration or two, and look at a little bit of the difference now in function and block scope within a function. So we'll declare X inside the function, which is no problem, and we'll give it a value of 10. And also inside the function, we'll redeclare Z, and we'll give it a value of 5. Now, when we look at the console, we have global 1, 2, 3, function 10, 2, 5, and block level 10, 2, 5. Block is pulling values from the parent, and my function is pulling the Y value it needs from the global environment, the global scope. It pulls that in and has 10, 2, 5. We have no definitions in the block level, and so it is also 10, 2, 5. So let's go ahead and add some definitions at the block level. And as you might expect, in this order, we get 10, 2, 5 from the function, and at the block level, we get 11, 2, 6, because we defined X and Z at the block level. But let's make a change and see what else changes in our output. All I'm going to do is move the console log lines of the function to after the block of code. This is our block scope. This is our function scope. And the whole thing is the function. So we'll move the console log lines that say function after the block. We definitely got a different result. Global is still 1, 2, 3. Block is still 11, 2, 6. But now function, instead of 10, 2, 5, is 11, 2, 5. And that is because when you use the keyword var, it is function scoped. Therefore, when we set x equal to 11 inside the block, because we used var, that value is available outside of the block in the function. Var is function scoped, not block scoped. However, using const, which is block scoped, only allowed the value of 6 to be available inside the block because const and let are both block scoped. And therefore, 5 is what is still printed in the console for the function. Giving it a value of 6 did not change the value when it reached here. However, var did. And that is worth noting when you're thinking about function scoped and block scoped variables. And that is a lot to take in today. So a quick recap, global scope, it's not in a function or in a block. It's really not desirable overall because it can cause mistakes and confusion because global variables are available everywhere. And sometimes more than one thing could be changing the value of that variable. And there's other things that could also cause problems that we could get into with more advanced topics. But global variables overall are not desirable. It would be preferred to have variables with local scope, and those variables are in a function or in a block of code with curly braces. And of course, those are not exclusive. You can have functions nested inside of functions. You can have blocks nested inside of functions. var instantiates function scoped variables. So if you do use var to instantiate a variable, it will ignore the curly braces if it is in a block of code. If it's within what would be considered a block scope, var will ignore that, and it will go ahead and break out of that and change the values above the block of code. However, let and const respect the curly braces. They respect the block scope value, and that is modern JavaScript. Overall, you want to use const and let, and of course, only use const unless you know you need to reassign the value. Use let if you know you will be reassigning the value. And just avoid var and leave it in the legacy code if possible. Let's start working with arrays. Arrays are a data structure in JavaScript, and I'll use the analogy as we start out with an array being something like a shelf that we're going to store things on. And right now I'm just going to build my shelf by defining an empty array, and the array is indicated with those brackets you see. So we've defined my array and it equals an empty array at this point. Now I cannot reassign my array. It's always going to be an array, and you can tell we've used the const keyword to make sure we cannot reassign that, just like we couldn't reassign a variable as we used the const keyword. However, the elements inside the array can be reassigned. They are mutable, and so we can add elements to an array by referencing the position they are in the array. And we do that with the brackets, and then we'll put 0 because we start counting at 0 just like we do the positions in a string. And so we have my array at the 0 position, and here I'll assign my name. And now on our shelf that is an array, in the 1 position we'll assign a number, and then in the next position we'll assign a Boolean value. So you can see we hold all different types of data in an array, and it's kind of like little storage locations. And you could look at the array as the shelf, as I mentioned, or a briefcase, or something like that where we're storing our data. You can actually even nest arrays within arrays, and we'll get to that. Right now, let's look at how we can refer to an array when we want to see it in the console. I'll type console log, and I'll just type the name of the array. I'm going to save the file and look at the console. We have a 3 over there, which indicates the length of the array. So yes, an array does have a length property, and you can see the array. So within the brackets, we have our string data, our numeric data, and our Boolean data, all within the array that has a length of 3, as you might guess. So let's take a look at that length property. And we refer to myArray.length as we have with other data before, like strings. And now we'll save that, and you can see we get 3 in the console. It has a length of 3. And let's look at the last element in an array, for example. So we'll go last element in an array, and we can view that. Of course, I'll type console log, then myArray. And instead of giving a specific number, say we don't know how long our array is, we can put myArray.length. But just like with a string, it's going to give, say an array, it gives the full 3 count here. We've got 3 items, and it gives a 3. However, we start counting at 0. So we have to say myArray.length minus 1, because actually our Boolean data is in the 2 position of the array. I'll save that, and you can see in the console, it says on line 16, we've requested the data from the last position of the array, and it prints false to the console. And what else? Oh yeah, we can refer to just any one item, kind of like we did there, but we didn't do it specifically. We can refer to any one. Requested the data from the last position of the array, and it prints false to the console. And what else? Oh yeah, we can refer to a string, how long view in an array, for example. So the console has a length of 3, and let's look at the last element in an array, for example. So we'll go last element in an array, and we can view that. Of course, I'll type console log, then myArray, and instead of giving a specific number, say we don't know how long our array is, say an array, it gives the full 3 count here. We've got 3 items, and it gives a 3. However, we see in data on line 16. And what else? Oh yeah, we can refer to just any one item, kind of like we did there, but we didn't do it specifically. We can refer to any one item of the array with its number. So if we wanted to view whatever was in the 1 position of our array, we just say myArray brackets and the number of the position, and there we go, we get 1001 in the console. One of the first things you may ask is, how do we add more data to our array? So let's go ahead and remove these lines, and we'll add something to our array. We'll say myArray.push, and now let's put in, let's put in school, because school just started, and we'll save that. Of course, we didn't log anything to the console yet, so let's bring back our array in the console, and now that we've pushed that data, you can see our array has 4 items, and we added the string school in the 3rd position of the array because it counts 0, 1, 2, 3, and it has a length of 4. So how do we remove something from our array? Well, we can say myArray.pop. Now if we log to the console myArray one more time, you'll see the second time we log the array to the console, it only has the 3 items again because we popped the last item off of the array. And further, we could define a variable to hold that last item if we wanted it, because pop will actually return the last item to us. So we can say const last item equals myArray pop, and here we'll put last item instead of myArray. And you can see now we have school in the console because last item is equal to the last item that was in the array before we popped it off of the end. We can do the same with the front of the array. So I will remove some lines, and instead of push, we'll put unshift, and here, let's go ahead with numeric data. Put the number 42 and unshift. We'll save that, and now notice we've got the number 42 at the beginning of our array. when we print it to the console. And what about removing? Oh, I should also mention that I said shift unshift adds to the array at the front, and when we push and add to the array at the end, if we assign variables to those, it is the new length of the array that is returned. So if we put new length in here, you can see now we get 4 in return. So when we add to the array, the return value is the new length of the array. And so we could also do that with push, and it would be length of 4 because we start out with an array that has a length of 3 until we add that new value. And so when we push and unshift, we are adding to the array, and when we pop, we are removing from the end of the array, and as you might guess, when we shift, if I can spell, we are removing from the front of the array, and instead of new length, we will have the first item of the array returned to us, and we'll log that to the console this time. And you can see Dave was the first item of the array. We've shifted, and so now when we shift, it does remove that item, and I will show that by logging the array right after this. And now the array only has 2 items inside of it. When we push items to the end of the array, we're adding a new number. So if we have my array 0 through 2 and we push something to the array, now we have an item in the 3 position. Likewise, when we pop something off at the end, it's from that last position. It doesn't really change the previous positions that were assigned, unless, of course, we don't assign something new and pop off the last one from the end like we could here with the 2 position. But it doesn't change the previous assignments of the position. So a good question would be, what about when we use shift and remove an item from the front of the array? What about the position of these items? Is 1001 still in position 1? Well, let's take a look. My array, and we'll put position 1. Log that to the console, and it's now false. So that is worth noting, that those positions are not locked in. If something is removed, everything shifts to the front. So the 0 position would now hold 1001, and the 1 position would now hold false. And what if we tried to log a position that no longer exists? What will we get in the console? Undefined. And of course, trying to do something to undefined, say call a method on something that is undefined, will cause an error. So we have to be prepared for that as well. What if we want to remove an item, an element, from the middle of the array, somewhere in there that is not at the beginning or not at the end? Well, let's take a look at that. There's a couple of ways to do it, and let's look at one that I will suggest you do not use first, but it does exist. We could say delete, and then we would say my array, and let's say we want to delete the value that's in the first position of the array, and we would just say that. And now let's console log my array and see what we get. Notice it says empty. So it doesn't remove that position of the array like you might think. It actually leaves undefined data. And we can see that when we go to the console one more time and say log my array position 1 to the console. We still have that position, but it is undefined. And once again, if we're not expecting undefined data, that can cause problems if we are trying to manipulate the data in some way that calls a method or something that will not work with undefined. So instead of directly deleting an element from the array with the delete, we can use a method, and that method will allow us to remove and replace, if we want to, elements in the array. And for that, we'll call our array, my array, and the method is splice. We tell the splice method where we want to begin, and in this instance, I'll say begin in the number 1 position. So this is where we have our 1001 value stored, and I'll say we want to delete 1 element from the array at that position, and we'll just stop right there. We'll save our file, and you can see now our array, when it's logged to the console, it just has 2 elements, and the element or value in the 1 position is no longer 1001, but it is false. That used to be in the 2 position, and it moved back to that first position, which is actually the 2nd position. I know that gets confusing, but we go 0 and then 1. And so you can use the splice method to do that. We could also use the splice method to replace that value or replace several values if we wanted to. So in this instance, we'll say we're just going to replace that first value. If we wanted to replace, say, the first and 2nd position values, we could put a 2 there. But we'll just put 1 again, and we want to replace it with something else. And let's say we want to replace it with the number 42, so that's what we'll put. And we'll save that. And now you can see our array has 3 elements. and instead of 1001, it has the number 42 in that position. So splice can be used to delete, splice can be used to replace. If we don't want to delete any values in our array, we can just put a 0 in the second parameter. Again, we're still telling splice where we want to start. So this still starts at the first position, but we are not deleting any of the elements in the array, and we're going to go ahead and insert one element with the value of 42. We save that, and we get 42 in front of the number 1001 that was previously in the 1 position, and now 42 is in that position of the array. Let's look at some more array methods. Right now, I'll delete all of this, and I'm going to just put some values in our array because it's easier to see when you know you have consecutive values what we're comparing. So I'll just do the ABCs in our array for a few letters. And would probably be good to stop after this one. There we go. A, B, C, D, E, F is what is in our array. We save that. We don't have anything logged to the console, and we're ready to check out the slice method on arrays. So if we say myArray.slice and we tell it to start in the second position, and that's all we do, we better set a variable equal to this because it is going to return a new array, and then we will log that to the console. And we'll see what our new array holds when we start slicing at the second position. And that's what happens. So we're at 0 for A, 1 for B, and 2, which is where we started the slice. And our new array starts at 2, and it goes to the end because we didn't tell it where to stop. The second parameter we could add would be telling it where to stop. And let's say let's stop at the 5th position, which it will not include that, whatever is at the 5th position. So 0, 1, 2, 3, 4, 5. Our new array should now not include F. It should just be C, D, E. Let's save, and that's what we get in the console. So that is the slice method. Now let's look at the reverse method. And that would just be myArray, and just say reverse, and we'll log myArray. It does not create a new array. And now we have the exact same array, but it has been reversed. So now it starts with F and it ends with A. There we go. A, B, C, D, E, F is what is in our array. We save that. We don't have anything logged to the console, and we're ready to check out the slice method on arrays. So if we say myArray.slice and we tell it to start in the second position, and that's all we do, we better set a variable equal to this because it is going to return a new array, and then we will log it goes to the nth position, which is 4, 5. What we get in the console. So we just, and now the next method we look at, and yeah, let's do join. Okay, join is going to take my array, and it's going to create a new string using the join method, and we will log this new string to the console. And you can see it takes each one of the elements in the array and it puts commas between them, but it has created a string out of all of the elements in the array. The next method we'll take a look at is actually a string method. So let's take this new string. We've already created a new string, and we will split the string, and we tell it what we want it to split on, and we're going to say split on those commas because you can see in the console our string has a comma between each value. So we want to split it based on that, and this is going to actually create a new array. So we'll log the new array. And we're back with that array we started with. So you can see we can take an array, turn it into a string. The string will be comma delimited by default. And then we can split a string what we want to split on, and we're going to say split on those commas. because you can see in the console, our string has a comma between each value. So we want to split it based on that. And this is going to actually create a new array. So we'll log the new array. And we're back with that array we started with. So you can see we can take an array, turn it into a string. The string will be comma delimited by default. And then we can split a string based on a value in the string. And the new array will not include whatever we split on. And there we split on commas. So the commas in this array are just to separate the elements. They're not part of the values of the array. So now let's split our array, my array, into, let's call it my array A, and we'll stop that array at C. And then there we go. I'll create a my array B, and it will hold our DEF values. Then we want to create a new array. We'll get rid of all of this for now, and we'll have my array A dot concat my array B. And then we want to log to the console the new array that is created. And we have our larger array again. So you can see that concat method joins two existing arrays. And let's do the opposite of this, and this would help you see it even more because it really didn't change from the previous array I had logged there. So if I do this, now you can see our array is DEF ABC because we put my array B in the first position and called the concat method on it, and then passed in my array A as the parameter, and it joined those two arrays into one using the concat method. There is a newer way to do this, though. Instead of using the concat method, we can use what is known as the spread operator. And we'll use the spread operator to create a new array, just like we're defining a new array. So that would be a blank array. The spread operator is 3 dots. So we'll put my array A, and then we'll once again use the spread operator and put my array B. What the spread operator does is it tells the array to not put itself in there. Like we're not creating a new array that has 2 elements, and each of those elements are arrays. We're creating a new array that has 6 elements because the spread operator says take the values in the array and spread them out to be individual elements. And so this should once again equal a new array that has the values of A, B, C, D, E, F. And we'll save this, and you can see in the console that's what we got. If we didn't have the spread operator there, we'll remove those. And once again, the spread operator is 3 dots. We would just have a new array that had 2 nested arrays, my array A and my array B. Let's take a look at how that looks. And now in the console, that looks completely different. You can see our new array has a length of 2, and it contains a nested array with a length of 3 and another nested array with a length of 3. So that is completely different than if we use the spread operator to actually pull those individual values out of each array and join them together in this new array. And there you see the result using the spread operator. Before we can finish our discussion on arrays, we need to come back to nested arrays and how to access values from single-dimensional arrays like we have been doing, then multi-dimensional arrays. So we can have a nested array or a array nested in a nested array even. And of course the rabbit hole can go deeper, but we won't go any further than at least we would take softballs, tennis balls. And then we have clothing shelves, shelf A and shelf B as well. And there's clothes on both of the value from a single dimension of this array, which is what we have here is a single dimension. We'll have equipment shelf A, and then we want to access, let's say, football. It's in the first position, and logging to the console is all that would take. Or we could log some clothes, and we could say clothes shelf B, and we'll go ahead and access what's in the first position there. Oh, let's access tank tops or sweat tops. They're in the 0 position. of shelf B, just so we're not accessing the same position from both. And we'll save that, and we get football and sweat tops logged to the console. That is a single dimension. But what if there was another dimension added onto this? And let's do that as these two different types of arrays, or not types, but two different things we have. We've got sporting goods equipment and we've got sporting goods clothes, sporting clothes. So those are both in their own departments. So let's go ahead and create arrays for those departments, and I will paste that in. So we have our equipment department now, and that has equipment shelf A and shelf B. We have our clothes department, and that has clothing shelf A and shelf B. And we have created separate departments for each of those, so we have separate arrays. Now those are nested arrays within another array. So you have the equipment department as an array, and it holds 2 arrays. And then you have the clothes department as an array, and it holds 2 arrays. So let's take a quick look at that. And I left something, oh, typo. There we go, semicolon. So now you can see we are logging these single items here, and then underneath that we have our arrays, and both of these arrays hold items. So if we don't want to log the full array here, how would we log those same items? Let's say once again we want to log football, but we're starting at the equipment department. We're not at the shelf yet. So the first thing we have to do is indicate which position holds the shelf we need. And that was shelf A, so that is the 0 position. So that indicates the shelf, and now we indicate where the item is, or the element of the array. So of that console, but we add one more level. That was a 2 our equipment department and clothing department log those same items, but it doesn't say that they're holding arrays inside there, except they are, but we don't see that at this point in the console. We just know the 2 items or 2 elements in our sports store array are arrays, and both of those arrays also have lengths of 2 for whatever they're holding. So now in our sports store, if we want to start at the very front door of the store and then identify the department, the equipment department was in the 0 position of the sports store, and then from there our equipment shelf that had the football was in the 0 position of the equipment department, and then we went to, oops, I didn't put the brackets, and then we went to the item on the shelf we wanted, and that added our 3rd dimension to get the same result, and that should once again send football to the console. Now let's go ahead and find a way to also send sweat tops to the console, clothing to a way of same values, additional old information that you need out of arrays. And so these are things that are worth practicing as you move forward with arrays. We are refactoring our rock, paper, scissors game in this video of line 1, and this is the game we made. This is the code right here I have open in this window, and you can see it